Can I get a thumbs up in the chat? I want to just check the how the video is coming through. If there's a window overlaying, give me a thumbs down or a thumbs up if it looks good. Cool, thank you. All right. So last time we left off on list methods and operations. I have some more here that we didn't get to, and then I have all of the methods listed here. So I think what I want to do is quickly try to go through these. I think we basically got through the major ones, and these ones will go fairly quickly. Zip has a little bit to it, but we'll see. And then just very quickly, I'm gonna kind of just try to blaze through the methods again, just to kind of give you all a sense of what these are and how to locate those and everything. So I think we'll forego the overview for today. Oops. Dang it, I need to do this. Cool. Let's try that. Okay, good. Like I said, let me copy these. Okay, so we'll start with count. Count's a really useful method for lists. I think about it as kind of being related to len a little bit, because it gives you sort of gives you a number of elements, but it's more specific than len, right? So the reason I bring that up is occasionally I'll see somebody kind of make the mistake of doing one when the other is appropriate, and I think it's because it's easy to think of one. It's easy to think of one or the other in similar situations, since in either case you're counting, you're counting elements, right? So just to juxtapose this, len, we'll take in, we can do list equals, right? And we can print the len of the list like this. 5, because there's 1, 2, 3, 4, 5 elements in that list. And count, let's see, let's do the same thing with this list. Let's count the number of 4s in that list. You say list.count 4, for example. So there's 2 4s in that list. Let's see how many 3s are in there. There's 1, 3. Let's see how many 0s are in there. There's 0 0s. Or let's do 9s. It's kind of better. There are 0 9s, right? So you can try to, I could see how many hellos are in this list, and there's 0. So you can try to count something that's not in the list. That's totally fine. It's just going to give you 0 because it shows up in the list 0 times, right? So that's count. Pretty straightforward. Do this. Zip, the zip function. So zip, you're going to encounter problems occasionally where you're going to be doing this. You're going to have, let me see if I can kind of create this. Oh yeah, let's just do this. Names equals a list of names, and let's say Joanne, Jason, Jesse, Joe, and let's do something like ages. Oops. Ages. Let's say 25, 33, 18, and 77. Okay. So, I mean, can you guess how this data is lining up? I'm literally going to line it up. So we've got two lists with parallel data. This is what we call parallel data. And, presumably you can deduce that, the first element in either, the nth element in either list corresponds with the nth element in the other list, right? So element 2, Jesse, in names corresponds with element 2, 18 in ages, right? So Jesse is 18 years old. So let's say you want to iterate through these lists together. So this is the kind of the problem that I was trying to create here. So this will happen not infrequently, not super common, but happens fairly occasionally, that you'll look at a problem and you'll think, how do I iterate through two things at once? The answer to that question is zip. So how do you iterate through two lists at once? And we could extend this, we could do favorite colors, and we could put everybody's favorite colors in there. I'm not going to do that, but we could extend this beyond two lists. We could do 3 lists or 10 lists or whatever. We could have any amount of lists that we wanted. So the answer to how do you iterate through multiple lists, or you could extend that beyond lists to multiple collections at the same time, the answer to that is zip. So we can do for, and I'm going to say name, comma, age, in zip, names, comma, ages. Just like that. Cool. Sorry about that. Hope that wasn't too loud. So if I want to print name, let's just do an F string. We'll say name is age, years old. So Joanne is 25 years old, Jason is 33 years old, Jesse is 18 years old, and Joe is 77 years old. Okay. So that's what zip's going to allow me to do. So notice I mentioned a function that does something similar, kind of similar, or has kind of a similar effect last time at the end of last class, which is enumerate. If you'll recall, an enumerate is something that you use all the time. And a lot of my for loops, I don't know if I'd say most, but a whole lot of my for loops that I write will use enumerate. And if you'll recall, enumerate, we pass in a list to be enumerated, and it gives us back two things to identify, to assign identifiers to. The first is the enumeration, the number. By default, that enumeration starts at 0, which is convenient because it'll follow the indices, the index numbers of the element, right? So this will give me, and that's why I call it IDX, which is short for index, right? So this will give me the index followed by the element, which in this case is numbers. And I've just been using lists of numbers here. So if I wanted to raise create another list, raise every number to the power of its index, or vice versa. I needed to use the index for something. I could use enumerate to get the element and the index, or the index and the element in that order, out of the list. Also, if you wanted to start it somewhere other than 0, you can specify that explicitly there. But if you don't specify it, it will be assumed to be 0. So enumerate, this is definitely something I don't want you all to forget. The enumerate function is very useful. It comes in handy a lot. Zip, I think I don't use as much, but it really is nice when you need it. It's just really nice to have to make parallel iteration easy like this. But there's other ways you can kind of get around using zip and enumerate with range, and I'll demonstrate that in a second here. But I don't know why you would, though. To be clear, these tools make this nice rather than doing everything with a range. So, anyways, that's zip. Somebody's asking, do you find yourself using zip and enumerate together at the same time? You're on, I think I know which question and learn you're on. Somebody asked me this question. Perhaps maybe it was you in a recent study hall. I don't quite recall it. I feel like last week somebody brought this question. There's a question and learn where it kind of makes sense to combine them. And I was just debating as to whether I was going to show that or not. But since you ask, I think I will. So to answer your question, there is a question and learn where I think it makes sense to use zip and enumerate together. And I'll give an example of something similar. I don't remember exactly that question. And I don't find myself using them together often. I guess I would say that. But I don't know, it depends on, like if I get it, I could see it being something that depending on what I was doing, I might need to use the two together often, but to this point, I haven't needed to use them together that often. But I'll give an example of that. So let's say, shoot, I wish I had a link to that problem, because it'd be nice to just go through that. I'll have to kind of make up a similar problem. Oops, I'll just keep that there. Let me just do this. Okay. More zip. Or actually, let me just zip and enumerate. So let's say I have to kind of think of a random formula here. So let's say I have A equals, and I'll just do something similar with B. And why don't I make B oh my gosh, careful. I'll make B a different size than A, because I want to show this too. So let's say I have some formula where I have to take the sum, so I've got my sigma. I'm gonna kind of do like informal math notation in plain text here. So the sum of A over B to the I, and we'll say I started I equals 0 here. We'll do this. And we'll say, yeah, we'll do that. So A, let's be clear about what these are. A list and B list. Let's do this, list A and list B. So A and B would be the elements from the appropriate list, right? A is the elements from the list A, and then B is the elements from list B. So what I want to do is raise or do like 4 over 1 to the power I, and I'm starting I at, why don't I start it at, let's do this. Oh, I can't do that. I'm making things too complicated. We'll start I at 1. No, we'll start them at 0. Sorry. I'm being needlessly fickle. Okay, cool. So we're going to say A over B, and we'll just raise that to I. So this first time it'll be 4 over 1, which is 4 to the power of 0, which is going to be 1. Okay, so if I say 4, so the sigma tells me 4, we'll say we have a few options on how we want to do this. I'll show it with a range. Well, yeah, I'll show it with a range first. I'll get the index first, and I'll say for I, A, and B, and then I'll zip range list A. So I'm passing in range. I know the question was about enumerate, and I want to get to that in a second here. Pass in list A, and then we'll do list A, list B. Okay. It's a little bit of a funky line. Oops, and I totally forgot the N. Okay, N. For I, A, B, N, zip. First we're doing the range because that's going to give me I. Then we're going to do list A and list B. Now you might notice list B is shorter. So you might think, well, what's going to happen, when we get to these numbers? It's just not going to get to these numbers. Zip is going to iterate through, and I'll show this. Oops. We've got a problem. List object cannot be interpreted as an integer. Right. There we go. Okay. So I'll just print, I'll print A and B like this. And you can see A is in the left column, B is in the right column in my terminal here. So A 4376592. Excuse me, 59, and it ends at 9 because we can only go up to that place because B is a shorter list, right? So if you're zipping two things and one of them has 10 elements and the other has 4, it's going to zip through 4. It's going to go through 4 iterations. So if they're uneven, the safe assumption is to not go over to the point where you don't have something for everything. Because of that, usually you're thinking about your data as, for the most part, having the same number of elements in any case. So we'll just do this. Okay, cool. So for I, A, and B, and zip range len list, that gives me the indices. Then list A, that gives me the A elements. List B, that gives me the B elements. And then we can do, we'll do an accumulator. Accumulator equals 0, and that's going to be A over B to the I. Let's see if I can hit the right keys there. print ACC. Okay, so this is the result of, okay. To the, because I didn't ACC plus equals, I was like, what happened? Okay, 13.87. That's our final answer. Cool. So this is how we can get, if we're zipping, this is one way we can get an index, right? But what I prefer, and this is where using enumerate kind of comes in. You can see this range call is a little funky, and it's also a little funky because maybe I don't know if list A and list B have the same length. Maybe there's, just getting the length of one of these random lists, it's fine, it'll work, but there's something about it that feels a little, I don't know, a little off. So it might be nicer to enumerate, and what my personal preference would be in this case is to enumerate zip. Now you can also zip in enumeration, but I think it makes more sense. It makes a lot more sense to do it this way. The problem is zip iterates through a list. Essentially, you can think about it as a list or an iterable of tuples, right? So that's why, let's come back up to this syntax, right? So zip name and ages. I'll give this example again. That's why I get to unpack that tuple into two elements. And I can demonstrate this. We'll call this tup. So for tup in zip, right? So I can do only one thing here if I wanted. And let's just print tup. We're going to learn about tuples fairly soon here. So we'll print the tuple. And you can see this gives me, in parentheses, groups of 2 at a time, right? So if you're not familiar with a tuple, if you don't know what a tuple is yet, it is a data type that is a whole lot like a list. If you understand mutability in lists, if you take away the mutable aspects of lists, you end up with a tuple. Literally, that's what a tuple is it's an immutable list. So this is giving me back essentially lists of 2 items, tuples we call them, containing the first and second elements, according to how I'm calling zip here. And a really similar thing happens with enumerate. Enumerate gives me, I won't run this code, but I'll just kind of give you a similar example. If I do tup here, enumerate gives me a tuple of the index and then the element, right? So here's the problem. I have to unpack a tuple inside of a tuple. So enumerate is going to give me back a tuple containing 2 things, the index and whatever the element of whatever I pass to enumerate is. What I'm passing to enumerate happens to give me a tuple, and it happens to also be of 2 things, although it could be of any amount of things. And so in order to unpack this inner tuple, I have to specify to Python that I want to pull out the elements in there in that tuple into their own elements by putting parentheses around here. So if I want to enumerate the zip, I have to put the second set of parentheses there. I'll show this again. We can do tup, print tup, right? Now if you look at this tuple, right, you got parentheses, it tells us we're starting a tuple. On the leftmost column, you'll see the indices, and then the middle column, the next item in that first set of tuples is another tuple. And in the left item of that, you have the elements from list A, and in the right column of that, you have the elements from list B, right? So it's tuple of index element, and the element is tuple of list A element, list B element. So in order to pull apart that tuple in the for list, I have to do I parentheses, and the parentheses are necessary here if I want to pull it apart, A and B. And then I have I, A, and B. There we go. Cool. So that's how you use zip and enumerate together. It's a bit of a weird one, but it's kind of fun. I was really happy when I figured that out. So anyways, we got a question. If I have 3 parallel lists, name list, age, name list, age list, and job list, how could I combine the three lists that has name, age, job? Good question. So let's say Joanne is a doctor, Jason is a trucker, trying to keep these all aligned and nice. And we'll say Jesse is a lawyer. I feel like I maybe have misspelled that, but I'm not going to worry about it. And then Joe is a programmer. Okay. So I've got jobs, and all I need to do is say job, jobs, like that. So then I could say name is 8 years old. They are a job. Joanne is 25 years old. They're a doctor. Jason is 33 years old. They're a trucker. Jesse's 18. They're a lawyer. That's kind of young for a lawyer. And then 77. Joe is 77 and is a programmer. They're a programmer. Okay. So that's a good question. And to be clear about this, as many lists as you have is as many lists as that you need to iterate through is as many lists as you can pass to zip. So you can pass however many things you want to zip. Let me know if that answered your question. Okay. Min and max. You're welcome. Okay, let's do min and max. So you probably guess what these do, at least fairly well by the name. Given a list, well, this is kind of funny. They actually will work with like a list of strings, but I think generally the application is a list of numbers. So you can think about it as given a list of numbers, min and max will give you the largest or smallest number accordingly. So let's do, let's just, I need a list. I'm like, wait, what do I need? I'm missing something. I need a list. Okay, there's a list. So let's say print max of list, and we'll do min. Okay, I mean, you can probably guess what's going to happen here. Oops. So 9 is the largest number, so max returns 9, and min is the smallest number in the list, so min returns 2. Or excuse me, 2 is the smallest number in the list, so min returns 2. Okay. Cool. Oh, okay. I feel obliged to talk. I don't want to like make these too complicated. I'm like, I'm not going to talk about min and max's behavior with strings because it's kind of silly. But I feel like I should. Hello. My name is Clark. Okay. So max is name and min is Clark. If you how do I say this? It's going to go, so min and max are going to go off of it, kind of what amounts to the Unicode or the Ascii value, the Ascii value of each character, right? That's one way of looking at it. The sort of the more higher level way of looking at it is it's going to give you, max is going to give you the element that is the furthest down the line in lexicographical order, and min is going to give you the furthest up the line in lexicographical order. So if you're not familiar with, I've mentioned this before, but if you're not familiar with what lexicographical order is, it's like alphabetical order that's sort of tailored to how you can express alphabetization in Ascii. It also includes number characters and number characters and special characters as well. So like alphabetical would sort words that have alphabetical characters. Alphabetical ordering is also agnostic to capital or lowercase letters. There's no reason in alphabetical order, when you're ordering something alphabetically, you don't take into consideration the case, whereas in lexicographical order you do. So in lexicographical order, it's I believe it's special characters, then numbers, then uppercase letters, then lowercase letters. If memory serves, that is correct. Occasionally I have to experiment and play around and like prove to myself that is the order or that it's not. But I don't really need to remember the order because I can just sort a list of strings and with special characters and numbers and digits and just see what the outcome is, and that'll tell you. But yeah, so this has to do with that. So this picks, max is going to pick, if there's a number that's, or excuse me, a letter that if there was a word that started with a Z, it would pick that word over a word that started with an A, for example. And min would pick a word that started with A before it picked a word that started with Z. Hopefully that's clear. Okay. That's why that works that way. So Ascii sorting order. Yeah, Ascii sorting order. Yeah. I guess, oh gosh, that's actually a really good way to think about this. Yeah, like if you sorted this list, max would give you the last element and min would give you the first. Why didn't I just explain that before? Okay, cool. So unpacking. Zip and enumerate kind of use some tuple unpacking. But we can do unpacking with lists and tuples alike. So what unpacking means is, let's say you have a list and you know how many elements, you can guarantee how many elements are going to be in this list, which is a little bit funny because a list by its nature is a data type that can change its size, right? We can append things, we can remove things, we can move things around. So we can change the value of an already existing element, or we can erase an element, or we can add an element. So the size isn't actually guaranteed, kind of. But let's say, so unpacking really only works if you are certain of that the list is going to have a certain size. So let's say we have a list of hello and world. Okay, so I could say A comma B equals hello world. So we covered some variable syntax like this a while ago, I think in the first lesson. And I probably mentioned, if memory serves, I mentioned like, don't worry about this too much now. We're going to get into it later when we talk about lists. So this is that moment. So if I print A, that's going to be hello, and B is going to be, oops, B, oh, okay. B is going to be world, okay. So the reason I make a big stink about these being the same size, if you know the size, right? Like what if I have another element? I'm going to get an error, right? It says too many values to unpack, expected 2. Okay, so I could do C. Let's try that. Okay, so if I have 3 elements in the list and I want to unpack the list, I have to unpack all of the things in the list, each to an appropriate identifier. Same thing goes in reverse. If I try to unpack 4 elements, let's do this. Let me just copy this really quick. So if I try to, so this will give me this error. And this will give me this error, which is kind of, oops, kind of the same thing. Oops, dang, I do that all the time. Okay, so if I try to unpack a list with 3 elements into 2 spaces, I get a value error that says too many values, these are the values to unpack. It expected 2, right? If I try to unpack 4 elements from a list that has 3 elements, 3 values in it, I get a value error that says not enough values to unpack. Expected 4, got 3. I don't know why it doesn't say for there, but yeah, same thing either way. So that's why I say if you know how many elements are in the list, you can unpack it. There's no way to make this, well, there's no way given this set of tools to make this dynamic in size, right? It's just, there are kind of ways of handling that in completely different ways, but a pure unpack like this, just a regular unpack, if you say there's 3 elements that you're unpacking, there better be 3 elements in the thing you're unpacking. No more, no less. So that's the thing. We got a question. Watch for value errors with unpacking. Yep. Just ensure parity between the number of elements you're unpacking and the number of elements in the list. Is there a way to dynamically generate variables? Way of dynamically generating variables? Nope, there's not. Not without writing like a whole parser that literally generates a Python file that then you somehow execute. But that's just a whole different kind of nightmare. So you could write Python that would literally generate a string, and the string was valid Python code. Then you could save that string into a .py document, and then you could use your Python code to access your operating system, use your terminal commands in your operating system to execute that Python file. But that's so, there's something really cool about that, but it's not what I would call practical, and it's definitely out of the scope of this. So the answer is no, not really. There's a way, if you have to have like a different name for each of those elements, with this, you have to just accept that unpacking is not going to complete the task for you. If I wanted like to handle each of these individually, I have a for loop for that, right? So I could do like a for loop, and a for loop is good for a list of unknown size. I can iterate through 10 elements or a million elements with the same for loop, right? So it just depends on the size of the list. So there need to be some you need some kind of loop of some sort to do that. But anyways, it's a good question. Yeah, I've never done that with the whole generating a string of Python code and then saving it to. I should do it because it sounds like it would break my computer, and I am fascinated. I've always kind of dreamt of that. But okay, any and all. Yeah. Okay. So any and all, these are simple Boolean operations. Boolean, I say Boolean because they return a Boolean value, true or false. You may recall that I touched on truthiness and falseness. So quick breakout here. What happens if I do this? Is this going to be an error, or is it going to give me true or false, or is it going to give me a number? Go ahead and put it in Slack. What do you think it's going to give me? Cool. I think people understand this concept. So it sounds like people remember the idea of truthiness and falseness. For numbers, values that are equal to 0, whether they're an int or a float, if it's exactly equal to 0, then it's going to be falsy. All other numbers, positive or negative, no matter how close they are to 0, whatever, they're all going to be truthy. For other types, a string is falsy when it's empty, when there are no characters in it. You might think, well, can a string have no characters in it? If it has no characters, is it still a string? Yes, and it's called an empty string, and it's just an empty string. It's still a string, it just doesn't have any characters in it, but it is still a string. So an empty string is a valid string, and it's falsy. Obviously, you can't have negative characters in a string. You can only have positive, number of characters in a string. So no matter what's in the string, it's truthy, right? So if I have the string false, the string false is truthy because there's characters in it. It's as simple as that. Same thing goes with lists and any collection type. If that collection Same rules for strings. If the collection is empty, that value is falsy. If it's got literally any contents in it whatsoever, it's truthy. Okay, so any and all kind of go off this principle. Any is saying, are there any truthy values? All is saying, are there all truthy values, right? That's it. If you understand truthiness and falseness, this is like bulk truthy checks, right? So this says, are there any truthy values? This says, are there only truthy values or all truthy values? So this is going to be true and true for both of these. Let's do 0. It's going to be false. And then, of course, if we do 0, oh, we'll do empty string. We'll do empty list. Yeah, so that's going to be falsy. There you go. Any and all. Programming Philosophy 101. Costco truthiness? That one went over my head. I bet it's hilarious though. Bulk truthing. Oh, that was a good one. Dang. Okay. I should have caught that. Do any and all only return a Boolean? Yes. They only return true and false. So they take in any collection and they tell you whether the elements. I guess they only take in lists or tuples. Come to think of it. Well, no, I have to see. Can we pass a string to any and all? Say any. I feel like this is going to be truthy. Yeah, okay. So I'm going to assume it's going to take in any collection type and tell me true or false whether the values in that type are truthy or falsy. Yeah, okay. Great. Okay, I was going to go over these again. But that took much longer than I thought it would. So instead, these are all the methods. Everything that we covered, there's a few things that we cover in here that aren't methods. Unpacking, parallel lists is zip, enumerate, let's see, sorted, reversed, min, max, count is actually a method, any, all. Len is not a method, sum is not a method, but I think the rest of them are. So there's a quick and easy way to get a reference for the what am I trying to say? There's a quick and easy way to get a reference for the methods for each of the types. You've seen me do this before. I'll demonstrate it again. So I like to do this in my terminal or in my in a Python shell. So I have a IPython session started up here. So I'll do dir, and then I'll just pass it a list because list is the thing that I'm curious about. I can do this. You're going to see all these dunder methods, all these funny looking methods with double underscores. They're called dunder methods. Ignore all of them. I know there's a little bit of a, you have to suspend your curiosity a little bit there, which can be a little frustrating, but I used to, well, I have a lecture prepared on classes that I used to go through in Premium Prep. We decided to omit that lecture this round in order to kind of repace the sort of beginning Python materials, and we needed to recuperate a day. But I am planning on giving that lecture probably later, probably not next week, but maybe maybe next week or 2 weeks in study hall. And when I pick a date for that, I'll let everybody know and make an announcement about it. And we'll talk about classes, and in that lecture, I'll talk about the role of dunder methods and what they are. But for now, I'm going to ask that you ignore them. You can look them up. You can look up what dunder methods are if you're curious, but you don't need to spend your time focusing on understanding those just yet, at least. So these are all the regular methods, and if I just copy paste these, you can go through. If you ever need to jog your memory on what methods are available for a given type, you can do that. We could do this for strings as well. There's a whole bunch for strings. Cool. Will you put Costco truthiness example in the chat? The Costco truthiness example, indeed. Okay. Okay. Let me pop that in the chat really quick. I think that was it. Yeah, okay. For dunder methods are referred to as magic methods. Yeah, some people do call them that because a lot of other languages that are kind of philosophically similar to Python, one in particular that I'm thinking of is kind of needlessly complicated, and Python is like wonderfully straightforward at times. So if you're coming from one of those object-oriented languages that kind of makes things feel like things are being made as hard as they can be made out of a matter of principle, and you come to Python, you think, oh, this is magic. So if you're learning Python like as your first language, it's a little weird to call them magic methods, but because the kind of the contrast, the context is lost there a little bit. But yeah, magic methods or dunder methods. Cool. All right. I'm thinking this is a good place to take our 5 minutes. We're through this part of the material, and I'm going to take a second and orient around the next half of the lesson. So go ahead and enjoy your break. We will reconvene. Let's just reconvene at a minute after the top of the hour. All right, cool, and we're back. All right, let's see. So we're gonna change gears. We're gonna get into while loops. So I gave a quick example about these. Somebody asked a question when we were talking about for loops. So we have just a little bit of an introduction into while loops. So I'm going to do that thing where I ask a question that I'm certain that I think most of you know the answer to, but I want you to be involved in this, and I want to kind of help establish this idea. So let's start off about talking about while loops by talking about if statements, right? So let's make this a little bit of a breakout. Go ahead and put it in Slack, like the anatomy of an if statement. Just a couple lines, fairly brief. The anatomy. Go ahead and write out, like, you could give an example and just sort of a description, a generic description of an if statement. I'll put a couple minutes on the clock for this. Okay, we got a few answers in here. Cool. Okay, so I'm going to go over this. Perhaps we need a bit of a refresher on this. That's okay. So we can say we have our if keyword, and then we have some condition, and then we have some consequent, or often called a block, right? So if, condition, consequent. So go ahead and put it in Slack. What is the definition of a condition? Put a couple minutes on the clock for this one too. Okay. We'll call that there. So a condition, and I'm seeing a lot of good thoughts on this, right? So a condition is the heart of an if. That's what makes an if useful, kind of. We get to check this condition, and based on the state of that condition, we do something or not. And if not, maybe we do something else, or we check a different condition, or maybe we just move on and do something else. So it allows us to execute code based on whether that condition is true or false. So to be clear, the way I always describe this as a condition is any expression that evaluates to true or false. Another way you could say that is any expression that evaluates to a Boolean. Same difference. So yeah, I'm seeing a lot of good answers on that. So that's a condition. So let's think about this if. What I could say is if a is less than 10, print a. So let's say we have a equals 0. So we'll just print fin. That way we know that the program is finished. And everybody will know how fancy we think we are by saying fin at the end of our program. Okay, so if a is less than 10, we're going to print a. So the way you could describe this is we have this if keyword that tells us we're going to check a condition, and if that condition is true, we're going to run the code. So let's look at a while loop. So I want to be clear about something, because this isn't, occasionally I will hear people refer to ifs as loops, and I want to be clear that ifs are not loops. Ifs are part of control flow, which just means checking conditions. Control flow officially formally has nothing to do with loops. We have one category, which is iteration, and a different category, which is control flow, right? So why am I talking about control flow when we're talking about loops? Okay, so here's a while loop. Who knows what the difference is between these? This code as it stands. How's this going to run differently than this? Does anybody know this one? It'll print forever, right? So you can think about a while very similarly to an if. The one difference is, okay, let's go through this if. We got a equals 0. If a is less than 10, which it is, that's true. We're going to print a, and then we're going to move on. That's where the difference is in the move on. While says, while a is less than 10, print a. So if a is less than 10, it's going to print a, and then instead of moving on, it goes back up and it checks if a is still less than 10. That's the difference. It's the only difference. And if checks that condition once, and if it's true, it runs the code. If it's not true, it doesn't run the code. And either way, if it's true or false, after the code has been run or not, it just keeps, the program moves on. It goes down the line to the next line of code. With a while loop, it continually, after it gets to the end of the body of the while loop, it continually comes back up to the top, and it checks if a is still less than 10. Cool, I'm just trying to catch up on comments here. Condition has to be present a is less than 10, stops when. Yes, cool. Awesome. It seems like people have a decent understanding of what's going on here already, so that'll help. We'll go slowly through this because I'm sure this is still a new concept to some of you, but I want to help root your understanding of while loops in your understanding of if statements that even though categorically we put these into two different categories, there's a mechanical similarity in terms of how they work, right? They check a condition. If the condition is true, they run the body of the code. That part is the same. What's different is when they get to the end, an if just keeps going, a while loop checks the condition again. So simple analogy, if you want to remember how while loops work, just think it's an if that checks the condition after it's done running the code. And it only stops checking that condition when that condition is false. Once that condition is false, it doesn't go try to check it again. Then it moves on. That's when it knows to move on. So that's a good way of remembering what I would say how while loops work mechanically, right? Like the mechanisms behind how a while loop works is basically the same as an if, except that it comes back up and checks the condition again if that condition was true before. And it only stops when that condition is false. That's the difference. So excuse me. So that's the mechanical, that's the way to remember like how a while loop works mechanically. But there's a lot of implications for what that means in terms of using a while loop. And there's some rules and some, I don't know, how would I say this? Some things that, some patterns that are pretty common. So if I run this code, which I will, I don't know if you can see this. I'm trying to select the code here. It's running extremely fast. So it's just printing out, and I can feel my computer heating up a little bit. I'm going to run that. I'll stick a break in there so it'll stop. So if I want this to stop, I have to increment a, right? So I have to say a plus equals 1. There we go. And that'll stop it. So once a is equal to 10, it's no longer less than 10. This condition is false. And then it stops, and then we end the thing, right? So this is, I want to show you something, and I'm going to admit that this is a little bit reductive. You're going to write while loops that this isn't quite going to work for, but it'll get you started, and it's a good way to think about a lot of while loops. So there's something that we're going to call a controller. This is kind of my own terminology around this. You know, I kind of think about it this way as a way that I hope to help simplify kind of using and understanding and being able to wrangle control of while loops, right? So we can think about, I think it's going to be safe to say most while loops are going to have a controller. And there's a number of different ways to write a while loop, but there's still going to be something that is sort of controlling it, right? And depending on, so the controller is the thing that ultimately inside of the while loop is going to change, and as a result of that change will lead to some condition being true. Eventually that will stop the loop, right? So if I, okay, all right, same deal. So this is that basic pattern. We have some controller, and you can see this is basically an accumulator pattern. It's essentially an incrementation accumulator pattern. While loops can get much more complicated than this. But yeah, there's almost always some element of the while loop that looks like this. even if it doesn't appear that way. There are some while loops that are designed to literally run forever. So if you need something that actually just does run indefinitely, that's what a while loop is good for. So you might look at this, and I think somebody asked a while ago when we were getting into for loops, like, why would you use a for loop when you can use while loops? Hopefully it's a little bit clearer now, right? Because what I'm trying to orient you around is, how do I make this thing not run forever? Which is just not something I have to think about with a for loop. When I write a for loop, it'll run until it reaches the end of the thing it's iterating through, and then it's easy, you know. So most of the time we have a solution that demands some kind of iteration. We know the source that we're iterating through. It's a list or it's a range. We just need to repeat something n number of times, you know. But so most of the time we need a loop. We can determine the amount of loops that's necessary to complete the problem before we start looping. And in those cases, we can use a for loop. We only need to use a while loop. We can also use a while loop in those cases, although we have to like manage it and prevent it from getting into an infinite loop, which is just, it's more code and it's sort of maybe more error prone, and you know, it's just more to manage. So why not just use a for loop kind of? But the only time we need to use a while loop over a for loop is when we have a problem that we can't anticipate. We're trying to solve a problem where it's impossible or too difficult to anticipate the number of iterations necessary to solve the problem before the first iteration, right? So there's certain problems where we can't know the number of times we need to loop until we just loop and find out whatever thing we're looking for, right? So if you think about, some of you may have written the next prime function, and we'll do this, we'll write this together. But if you think about, like, if you have a way to determine whether a number is a prime number or not, if I give you a challenge like write a function that takes in a number and finds the next prime number after that number that you handed it, right? So it takes in a number n and it finds the next prime number after and not including n, right? So if n is a prime number, let's say 13, next prime will take in n, it'll take in 13, and it'll return 17, for example, because 17 is the next prime number after 13. So in that scenario, given what we know and what has been discovered and proven about prime numbers, we can't know a priori the distance between any two prime numbers without just checking every single number between 2 points, right? To see, you know, is the next one prime? Okay, that's not. Is the next one prime? Okay, that's not prime. Is the next one? Okay, that's a prime number. So you just have to check every single number until you find a prime number. So here's a little trick. If you're scratching your head on something and you're trying to make a for loop work, and you think like, I just need to loop until I find such and such, that until should be a trigger. You can think of an until as sort of a kind of a synonym for while. I actually wish Python had a loop called until, because it would, you know, given the semantics of the word, it would check the opposite condition of while, but that's neither here nor there. But for our purposes, you can think, if you're looping through something and you're like, I just need to loop until this, that means you need to write a while loop. And almost all while loops are going to have, and all the ones we're going to discuss are going to have this sort of controller somewhere. And I'm not going to call it controller, but just look for that. The controller is essentially something that will be checked in the condition that ends the while loop. And there's a few ways to I'm going to show you a variation on this, but there's it's the thing that leads to the condition that ends the while loop being true, even if it's not checked directly in the condition. Sometimes it's hard to see, there can be a little convoluted, but sometimes the controller is not checked right in that condition. Usually it is, or is somehow checked in there, but even if it's not, it's the thing that leads to that condition being true, or to that condition leading to a stop to the while loop. So, and it's always altered in some way. In this case, I'm doing a simple incrementation, but the way that I could alter this could be any level of complexity, right? Like maybe I only alter it through certain trips of the loop. Maybe I alter it differently based on different conditions in the loop. Maybe I alter it by some increment, that maybe a random increment, or maybe some increment that I determine through some other process, so this increment does not need to be a simple add one at a time, but I'm just doing this just to keep things simple for demonstration purposes. Okay, so let's jump into this. I want to give you an opportunity because I want to do a project, and let's work our way up towards building next prime. But in order to build our next prime, we could build the whole thing in one function, but it sure would be nice. It should make a lot of sense to have an isPrime function. So isPrime is going to take in, and it's going to return true or false. We'll say true if n is a prime number, else false. There we go. Cool. So that's going to be your isPrime function. So I want to give you all, I know this is a function you all have seen. It's probably something that you have in your notes somewhere. Give it a good honest go about writing this from scratch. And I'm going to write one at the end of it. I'll just put a couple minutes on the clock and wait for you all to write an isPrime function. Now your isPrime function is going to use a for loop. And then the next prime function will use a while loop. Oh, sorry, I didn't see we had a question in here. I'm always glancing over at the questions to see if something says at Clark in there, and that helps me see it. So if you ask a question that you want me to answer, I'll put at Clark in front of it, and I'll be more likely to see it quicker. So sorry to leave you hanging. It says if you use a Boolean flag for a while loop, can you set the condition to continue while flag is either false or true? I think if I'm understanding what you're saying, then yes. Kind of no holds barred. There's sort of a real like do whatever you want in a while loop. There are very little restrictions, which is what's useful and also what's annoying about them. It's a power and responsibility thing, you know. They are very powerful. They're very simple. Just checks the condition, runs forever as long as that condition is true, until that condition is false, and then yeah. Will I clarify what I just posted? Yeah, so that's just what I just posted is basically a small doc string that tells you how an isPrime function would work. So what that says is isPrime takes in a parameter called n and returns a bool, and then true if n is prime, else false. Else it returns false. Apologies for the kind of extreme shorthand on that. I maybe could have like made that a bit clearer and kept it off of just one line. Yeah. Okay, that's time. Okay. I'm hoping people are doing all right on this. Give me a thumbs up if you want another 2 minutes. Or a different emoji if you want to move on. If I get 4 thumbs ups, we'll do another 2 minutes. Okay, cool. We're going to continue on this one. We only got 3 thumbs up, sorry. I am going to show a solution, so don't worry, you will have a working isPrime function at the end of this. So I'm going to say def, and you could try to beat me to it if you're close. I'm going to write my isPrime function, isPrime. We're going to take in n. And for now, I'm going to pass. And first thing I always like to do is write some tests. I just want to test every number between, let's just test every number between 0 and 20. So I'll say for I in range 20. That's actually going to include 19. That's fine. Doesn't really matter. I'm going to print I and then isPrime I. IsPrime of I. So this will tell me if I is prime or not. So first of all, I'm going to say if n is less than 2. If n is less than 2, I'm going to return false. I'm just going to say it's not a prime number. Then I'm going to say, excuse me, for I in range. Now this range can get pretty fancy. There's a few different places to start it. There's a few different places to stop it. I'm going to do a semi-optimized version. The unoptimized, the least optimized version you can do is just from 2 to n. You're checking a lot of numbers that you don't need to check. So the way you can minimize that space is by saying n, let's see, n to the power of 1 over 2, which is the square root of n. That's going to give me a float, and I want this to be an int because I can't pass a float to range, so I'll just cast it as an int. And we do need to include the square root. We want to check the square root because it won't always be, but sometimes it's a valid thing to check. Okay, so for I in range 2 up to the integer of n, the square root of n plus 1. That's just a little bit of an optimization. If you wanted to keep that simple, you could put n in there. I do want to be clear, if you're going to put n in there, don't do plus 1 because n is divisible by itself, and we don't want to do that. So now we're just going to see if any value of I is a divisor or a factor of n. So I'll say if n mod I equals 0. If n mod I equals 0, I know I goes into n an even number of times, which means n is not a prime number. I don't need to do any more checking. I can stop the loop with a return, and I can return false because we found a value of I that divides evenly into n, so we know n is not a prime number. Then we can return true, just like that. So if you want the isPrime function, I'm going to paste that in. You can feel free to use yours, and I would test it to see if you get the same thing as I do. And I'll just put in this output so you can match it. Let's do this. There we go. Nope. Just copy that. And here, OVS overlay. Dang it. What is with that? Is it gone? I don't know why it just randomly starts showing the OBS overlay. That's just kind of annoying. Let me just stop the screen share and restart it. Maybe that'll help. Okay, is the OBS window gone? Weird, okay. Cool. Let me know if it pops back up randomly. Okay. Next prime, okay. So you can use those tests to test your isPrime function to make sure it's working correctly. All right, so we'll spend a little more time for this one. I'll give you a second to test your isPrimes. You can use yours if you want, or you can just use mine. And the next one we'll do, and I'll write an actual docstring for this one. Next prime. We'll take in input, or let's say argument is in, which is an int. Sorry. In is an integer. Yeah, n is an integer. Return the next prime number after n. So the return is also going to be an int. So it's going to return an n, which represents the next prime It's going to return an int representing the next prime number after n. All right, we don't need to format anything. There we go. So there is the docstring. And I'm going to put, so this one you're going to need a while loop for. I'm going to put 5 minutes on the clock for this one, so we got a bit more time for this one. I want everybody to have plenty of time with this one. I know I cut the is prime a little short. I initially put 5 minutes on the clock. We're almost at the 4 minute mark. I am going to put another 2 minutes on the clock for a grand total of 7 minutes. I'm getting the feeling that we're going to need a bit extra time. So I want to make sure everybody has plenty of time to give this give this a shot. Give me a thumbs up in the chat if you want another 2 minutes on this. Don't be shy. I'm willing to give extra time on this. I certainly won't hold it against you if you want a little extra time. So. Okay. Could you use an unpacking, like the unpacking like we talked about previously? If that's what you're asking about, I can't think of a way to do that here. Perhaps. Okay. Yeah. I'm not sure about that. Perhaps you're thinking about it in a way that I don't think about this. So, but no, there's no obvious way to use unpacking that I can think of. Cool. Okay. I'm not seeing any thumbs up. I'm not seeing anybody asking for more time on this. Feel free, if you want to put the finishing touches on this and pop it in, you can do that. I am going to show a solution now. Okay. So I'm going to just kind of appropriate these tests. And we're just going to do next prime like that. And I'll say def Okay. So def next prime is going to take in n. Remember here, if I get a number like 13, which is a prime number, I don't want to get 13 back. If I pass in a prime number, I don't want to get that number back. I want to get the prime number that comes after it. Cool. So there's a few ways we can proceed here. We can say while, and I want to use a while loop here because I don't know how many numbers I need to check until I find a prime number. It could be 2, or it could be hundreds potentially of numbers that I need to check. So since I can't determine, I don't have like a finite iterable to put into a for loop, I have to use a while loop. So I could say while not is prime, n plus 1. We're going to check the next one after n. N plus gets 1. And then this is going to increment n until n is prime, and then, or n plus 1 is prime. And then since we checked n plus 1, we are going to return n plus 1. We'll return 1 more than whatever n was, since that was the number that we determined was prime. So to be clear, the reason I'm doing plus 1 here is I don't want to check n. I want to check the next number after n. I could take like an incrementation step and do like n plus gets 1 if I didn't want to do that, and then I could like clean this up. I might do that. Maybe it's a little more explicit for you. It's a little clearer, but I don't need to do that. I can just skip that step and do this. So this will give me a next prime function. You can see the next prime after 11 is 13, next prime after 12 is 13, next prime after 13, 14, 15, 16 is 17, etc. Okay. So earlier, and I saw somebody actually do this, and I think that somebody's heard me talk about this. Let's see here. Oh, I see that question. I'll get to that question in a second here. I wanted to give an example of a different way to write this condition, right? So one thing here, I was talking about try to keep an eye out for what the controller is. That initial while loop I wrote, this has that sort of signature stacking pattern of a small accumulator, right? Where you have like 2 lines up at the top, tabbed left, the accumulator, and then the loop head. And then you have your incrementation inside, right? This looks like an accumulator pattern. It's a very straightforward accumulator pattern. What's my accumulator, or excuse me, what's my controller here? Also, somebody's asking, is my input a list of integers? No. So if you look at the doc string I wrote, the argument is n, which is an integer, a single integer. If I wanted to specify a list of integers, I might do like list int like this. But yeah, I would make it clear if it was a list. The range is to just have a range of numbers, and I'm checking one number at a time, each one in succession. So the controller, okay, yeah. So we're looking at for what the controller is. Go ahead and put it in Slack. What's the controller here? So the controller is a thing that changes. It's an object that changes in the loop that that either directly or perhaps indirectly leads to the loop ending. Yes, so it's n. And this is maybe one layer more abstracted because I don't have that, n equals whatever up here. I could do that. You could do counter equals n, and then you could do counter here, but we can just do n, and that's fine. It's not gonna mess with anything outside the function. Integers are immutable, so they're safe from that. We don't need to use n for anything else, so I might as well just use it as a as an identifier to just hold the thing that I'm counting, so I can reappropriate it as a counter in this case. Real nice and simple. What's the controller object that changes the loop leads? Okay, yes. Okay. So there's another way to write these conditions, and it's actually the way that I prefer. I'll just start over. So here's what's going to happen to you a lot while you're writing while loops. Okay, so imagine you're in the middle of a project, you're thinking through a problem, you have to implement this function, you've got a lot of things in your mind that you're juggling, you're kind of in the zone thinking through the problem, and you go while, and then you have to think about this condition. You have to sit here and think, what's the condition? What's the condition? And what can happen a lot of times is this can feel like a point where you can get stuck thinking about what the condition is. So what I started doing out of kind of raw laziness is just saying true. I don't really want to think about what the condition is right now. I just want to get in and start writing the looping logic. And once I get into thinking about the logic inside the loop, invariably it becomes obvious, usually fairly quickly, what that condition is. And as soon as it becomes obvious, I write if, I check the condition, and then I break. In this case, I'm actually going to return, which is going to act as a break as well. So we could say while true, n plus gets 1, if is prime, n, return n, just like that. So I like to do things this way. Most of my while loops start off this way. I recommend this as a good way to start solving a problem with a while loop, because it's usually easier to think of this condition. If you'll notice, let me retype my old solution, which was while not is prime n, while n is not prime, and we're doing n plus 1 here, right? Look at this condition. I mean, it's less lines of code, but it's this is not terribly bad, but it's more complicated than this, right? We have this not and this n plus 1. There's I've written this function a number of times and practiced honing this down. These solutions are from memory, and I kind of got to this from not a whole lot, but a bit of practice to get this function to this state, right? So it's not terribly difficult in this example, but some conditions are a lot more complicated. And the reason I like to do things this while true, what this says is just loop forever, right? So any expression that it evaluates to true or false, true is an expression that evaluates to true, so I'll just use that. So this just says loop forever. You're basically just saying, oh, just keep looping, I'll tell you when to stop. And the way you think about this condition tends to be sort of framed as a positive, whereas this is framed typically as a negative. And it's just sort of one of those psychological things, like it's easier to conceive of a positive statement, even if it's logically identical to a essentially the same statement with the same premises and conclusions framed as a negative. So I find it easier to do this. If you're having let's call it while loop block or while loop condition block, and you find yourself just sitting there thinking, what should my stopping condition be? Just do a while true, jump into your logic, and see if it comes to you. If you don't want to do a return, you can just break under that condition. The other thing I like about this is a lot of while loops have other exit conditions, right? Like, maybe I'm looking for, maybe I'm doing some operation that deals with numbers within a certain range, and I want to keep doing that operation so long as that number is within that range. And maybe I reach some certain sum, and that's like the main condition that I tell the loop to break under. But maybe if that number at any point falls out of that range, maybe I want to break under that condition as well. So you end up writing these other exit conditions anyways. It's something that you're going to have to get used to. A lot of while loops will have multiple conditions that lead to a break. And in that case, I kind of prefer to do it this way because it keeps them all of a piece. So I like this because this is the simplest looping construct that you could think of. It's also very powerful, and it also feels a little dangerous, which I think it's kind of good because it is. While loops are prone to infinite loops, this is an explicit infinite loop. So it reminds you, you better be the one to stop this. You better be in control of this, otherwise it's going to be out of control. So I think there's a number of advantages to this. You don't have to do it this way. And one thing, if you've heard me talk about test-driven development, we talked about like red-green refactor in a recent study hall. You can think about your first solution doesn't have to be your final solution. Your first solution just has to work. So write a first solution. If it's sloppy, who cares? You can come back and write a second solution that's better, and then maybe do a little research and then write a third solution that's really awesome. So you can just think about, okay, if I write this while true, maybe that'll just get me to solve the problem, and then I can refactor that code into a way that I'm more pleased with, into a form that I prefer, if you prefer to do things this way. But I just wanted to mention that. All right, cool. We got a couple questions here. Will you encounter any Stack Overflow problems with while true? No. While true does not add stack frames. Recursion does. So we're breaching into a different topic related to iteration. It's a different iteration topic. So just like while loops can solve any problem that for loops can solve and more, recursion can solve any problem that while and for loops can solve and more. Recursion is kind of amazing. It's really cool. I'm not going to cover it in Premium Prep. I actually haven't done any recursive problems in a long time. I'm a little rusty. I might put together, I think I will. I think I'll put together like a little thing on recursion for a study hall maybe next week. It's definitely not, if you're curious, go look it up. Go look up some recursive Python problems. But essentially what it is you define a function that calls itself within itself, right? So you do def my function, and then inside that you're calling my function. So it's a function that calls itself. It's called recursion. And it is, in terms of the problems that it is capable of solving, it is a superset of all iteration patterns. And there's some really kind of mind-blowingly cool things that you can do with it. So it's the most powerful iteration. It is capable of solving problems that in Premium Prep we're not concerned with solving. It is something that at some point in your career, I think it's safe to say you'll need to know. The DSI does cover it a little bit, and that's a good place to learn it. So I don't, I'm not going to get into all those weeds here, but it's really cool. Okay, we got another one. Let's see. All right, that actually puts us at time. I'm going to wrap up class here. I'll stop the recording as well. I see a couple questions.